All right, so log day 2 notes is all about properties of logarithms. So let's take a look at page 1. So it says two exponential expressions can be multiplied only if their bases are the same. And in that case, what is done with the exponents? So in highlighted yellow, we have the situation where the bases are the same and we are adding the exponents. So in this case, the exponents are added. Let's take a look at the next situation when the bases are the same and you are dividing. What do we do with the exponents? We subtract them. All right. Um, so similar, excuse me. So similar relationships exist between log expressions that share the same base. So we're going to need our calculator, and then we're going to be looking at some situations here. So if we were to take a look and focus on log 39. So let me just do this here. Log 39. So 3 to what power gives you 9, right? So it's going to be a 2. And then log 3, that's going to be a 1. So when we do this, we can simplify each log one at a time. But notice what happens when I go log 327, we get 3. So again, you can double check these with your calculator. Log 232, and then log 4, that gives us 5 minus 2, which is 3. And then log 8 also gives us 3. Okay, log 8 in your calculator and log 4 in your calculator. You should have 3 plus 2 is 5, and then log 232, 5. And so again, in your calculator, you're trying to pay attention to what do you notice. Log 381 minus log 9, and then we have log 9, ln3 and ln2, and then ln6, ln12 minus ln3 versus ln4. All right, so based on our observations, make conjectures on how to complete the following properties, then write in words what the property says. All right, so here we have addition property of logs. So if we have log base b m plus log base b n, based on that observation that we just did, it would be the log base b of n times n. Same thing with ln. So when multiple logarithms of the same base are added, the result is a single logarithm, so one logarithm of the same base whose argument is the product of the arguments. So in other words, this was my original argument when I were adding them together, and now I have the product of those arguments. So under subtraction property of logarithms, so here's our situation. Again, the bases are the same. When you're subtracting, those arguments are divided. So when multiple logarithms of the same base are subtracted, the result is a single log of the same base whose argument is the quotient of the arguments. So now we're going to use our calculator and find the values of each of these log expressions. So when you see an argument that's 5 squared, or any argument that's raised to a power, that is the same thing as log base 225. So you could simplify that. And then what we end up getting in our calculator is 4.644. Remember, 2 to the 1/2 is like the square root of 2. Again, use your calculator, always go to 3 decimal places. This is just calculator work. Make sure that you're getting these numbers. If you're not, make sure you come and ask questions, and I can show you what you might be doing wrong. All right, based on our observations in those calculations, make a conjecture on how to complete the following properties, and then write in words what the property says. So it says power to the coefficient and vice versa property of logarithms. So notice that there was a coefficient in these situations, and then there was also a power that the argument was being raised to. So here's the power that the argument is being raised to, and you're taking that exponent and you're multiplying it by the log. So it comes out in front. So the exponent of the argument of the logarithm can be rewritten as the coefficient of the logarithm and vice versa. So again, if I had a coefficient of a log, I could rewrite that as an exponent of the argument. All right, so on 1, it says rewrite each expression as a rational number or a single logarithm of the same base. So let's take a look at this. The bases are the same. So we are going to multiply 6 times 8/3. That's going to give us 16. And then if we can evaluate that, we want to. So log 216 is 4. All right, remember what this coefficient is. There's 2 coefficients, so we can rewrite that. Those coefficients become the exponent of the argument. Remember when subtracting its division. So we've got the cubed root of x over y squared. And then that's going to be our final answer. Number 3, we've got our argument plus another argument minus x cubed. So we're going to multiply, just go from left to right. X squared plus 2x, all I'm doing is multiplying these two guys together, right? Distributing. Minus ln x cubed, which means it's going to turn into a quotient. X squared plus 2x over x cubed. And then the only thing I did here was factor out. Let me change this here. I factored out an x. So that I can reduce that. And I have x plus 2 over x squared. All right, number 4. Okay, so the only thing I did here was I took that 2 and gave it to that 3. That's 3 squared. That's where the 9 came from. That's the only change. Then it's going to be multiplication. So x times 9 is 9x. Now it's going to be a quotient, 9x over y. All right, this 3 becomes the power. This 2 becomes the power. This 1/2 becomes the power. All right, so now we're going to multiply. And then now we're going to do the quotient. Simplify anytime that you can. I couldn't simplify here. There were no like terms, but I definitely could do this here. Remember the properties. When the bases are the same, it's and you're dividing, you subtract. So 5 minus 1/2, right? So that's going to be x to the 4.5 or 4.5. And then that's going to be x to the 9 over 2. Okay, so that's where they got that. All right, so now we're going to x minus 3, and then it's plus 2x. It's still multiplying. So x minus 3 plus ln 2x. All I did here was take that 3 and give it to the power. So we're still multiplying 2x times x minus 3, and I'm distributing. And then from here, I'm using it as a quotient, and then I'm factoring out the x. So I would end up with 2x minus 3 over x cubed. That x goes away, it becomes an x squared, and that's how we end up getting, oh, that should be a 6, sorry. And then we go number 7. That 1/2 is a power. The 2 is a power. Remember, we are taking this. There's no multiplication, so it's over ln y squared minus ln z. You can do it one at a time, but you also know that it's a quotient. Ln z is going to be on the bottom, and so you could write it like that. Okay. All right, so we're going to go backwards a little bit right now. We're rewriting each of these single logs as multiple logs, and it's referred to as expanded form. So you're going to use those properties and we're going to go backwards. So again, remember the base stays the same. Remember what you are doing on xy squared. It's x times y squared. And then remember what that 2 can do. That 2 can go out in the front. All right, so let's think about what this is. X times y to the 1/2 power. And then that 1/2 power can go in front. Now we've got a quotient. So we're working backwards, x cubed minus. All right, now number 4, we've got a times b over c squared. So ln ab minus ln c squared. That 2 can go out in front. And remember, we need to separate these because they all need to be their own logarithm. All right, x plus 2 over x squared. So x plus 2 minus ln x squared. Take that 2, make it the coefficient. 2 times a times c, 2 times a times c over d to the 1/2, right? Square root. Okay, so from here we need to break up the 2 and the a and the c. And then anything that can be simplified, that's what you want to do. Anytime that you can, log 2 is going to be a 1. Okay, remember 2 to what power gives you 2. All right, x cubed over yz. All right, so x cubed minus yz. So we got 3 log x minus. Now remember, this was subtraction of yz, but I'm breaking that up. So do not forget to put that in brackets so that you can distribute that. And there we go. All right, now we're going to talk about solving by rewriting each side as a single log with the same base. Then set the arguments equal to each other. Then in the boxes to the right, we're going to check our answers. If the equation has no solution, specifically explain why. All right, so we're going to rewrite this as one log, and then we are going to work through this. So what I want to do here is take my 2 and make it a power. So when I have log 2 squared, then I'm going to simplify that, and that becomes log 4. Okay. And so then what I'm going to do is combine these together. Now, once the logs are equal, I set those arguments equal to each other and then solve. Okay. All right, so here's our check. We're going to go back to the original, and everywhere where there was an x, we are going to replace it with 3. So log 3, and this 3 plus 9. And so I have here log 3 plus log 4. That's the same thing as log 12 equals, and then log 12. So that's going to work. All right, so let's take a look. Base 3, I've got x minus 4 over log 3, 2. Then it's going to equal x plus 1. So let's take a look at what that's going to look like. Remember, once the logs are equal, we set the arguments equal to each other. And then now I'm just going to multiply by the denominator. So I've got x minus 4 equals 2x plus 2. Solve for x. Now, x equals negative 6. And I say that that's no solution. Let me tell you why. You can never have an argument that is negative. So that's what happens when we go to check. So when we go log 3 and then we plug in negative 6 minus 4, and then the rest of that over here, we end up getting log 3 negative 10 minus log 3 2 equals log 3 negative 5. In your calculator, if you were to put log negative 5, you are going to get an error. Okay, so you can try that right now. Just try log negative 5 and you get domain error. And that's because when you have a base, 3 to what power is going to give you a negative number? Well, that's impossible. You can't start with a positive, raise it to a power, and then get a negative number. So that's why it's no solution. The argument of a logarithm must be positive. That does not mean that your variable can't be negative. All right. It's when you're doing the evaluating, it's the log that can't be negative. So be careful. All right. Sometimes our answers can be negative, but not the argument. All right. So here we go. We've got log 2, x plus 2. So we're just going to use our properties, right? We're multiplying, we're distributing, and then we're rewriting that as 2 to the third power, which is 8, which is how I got that. Set these arguments equal to each other. It's quadratic. Try to factor if you can. So remember, we got to set this equal to 0. And then we factor that, we get x plus 4x minus 2. That means we get x equals negative 4 or x equals 2. But we need to check, okay? So don't cross this off yet. We need to check it. So we've got, let's check x equals negative 4. So I have negative 4 plus 2. I'll do this over here. The fact is, right here, I can automatically say that's going to be impossible, right? Because our argument cannot be negative. So let's check now x equals 2. So I've got log 2 plus 2, plus log 2 equals 3 log 2. All right, so when I do this, this gives me log 4. And I think about what that number is. 2 to what power gives me 4? Well, it's 2. Log 2, remember what that is. 2 to what power gives you 2? So that's a 1. And then this is 3 times log 2. Log 2, we just said was 1. And so 2 plus 1 is 3. 3 does equal 3. So x equals 2 is correct. Okay. All right, so let's take a look at the next one. So again, I'm using these properties. X plus 3 over 2 is equal to ln. And then I'm multiplying the 3 times the 2x and the negative 1. Set these guys equal to each other. Get rid of the denominator by multiplying both sides by 2. Distribute, solve for x, and I get x equals 9/11. So if I were to take my calculator, and I'm going to go 9/11 plus 3 minus ln 2. When I put that in my calculator, I get 0.646 da 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 da. And then I want to check ln 2 times 9/11 minus 1 plus ln 3. I put this into my calculator and I get the same thing. So I'm good. All right, last one here. So again, using properties, getting them to be equal to each other so I can set the arguments equal. Again, anytime you have a fraction, multiply both sides by that denominator, distribute, and we get 12/7. So if we're to quickly check, ln 2 times 12/7 minus 3, does that equal ln of 12/7 minus 2 ln 2? So I put this in my calculator and I got negative 0.847. And that is going to be equal to, I put this in my calculator and got the same result. Okay.